In 1670, Britain experienced a major increase in farm yields during what is known as the British Agricultural Revolution. The revolution centered on new methods of crop rotation. Previously, once a piece of farmland had been stripped of its nitrogen, it was turned to fallow and left unfarmed for several years until nitrogen levels had returned to acceptable levels. The revolutionary idea was to instead deliberately plant clover, which has the effect of returning nitrogen back to the soil and rendering it farmable only after a season of rest. Additionally, the clover provided an excellent source of food for cattle, whose manure further fertilized the soil. These increases in efficiencies provided a food and labor surplus that allowed many British to specialize in non-farm trades. Britain's new colonies in America provided raw materials that were scarce on the rocky island of Great Britain. The raw materials were shipped back to Britain and then manufactured into finished goods, which were then in turn sold to Europe and the colonies. Adam Smith, the father of capitalism, proclaimed in his 1776 masterpiece, The Wealth of Nations, that nations derive power from the level of goods they produce, not by the amount of gold sitting in their coffers, which was the belief of mercantilism that had dominated for centuries before and had kickstarted European colonial ambitions in the first place. His beliefs became popular among the royal family of England, who were convinced that if Britain focused on creating factories to export finished goods and then reinvested that gold received into increases in production, the country could become an unstoppable dominant global power. Britain's switch from a primarily subsistence-based agriculture society to one of a manufacturing society required additional energy than what could be obtained from wood, which had been the traditional fuel source on the island. While coal had been used as a fuel source in China since 3490 BC, this was since the coal was very close to the surface, oftentimes exposed, and therefore was very easy to harvest. This was not the case in England and Wales, where underground mines needed to be constructed to get at the coal. Underground coal mining created several new problems, including the paramount issue of how to remove water from the mines after it rains to stop it from flooding. In 1698, Thomas Savery invented the first steam contraption to solve the issue of mine flooding. The contraption used coal from the mine itself as fuel to boil a reservoir of water. The steam created then flows into another reservoir where it is trapped and condensed. Rainwater then flows into another pipe situated above the steam reservoir. The steam is released with a lever, with the escaping pressure pushing the water up a long, thin pipe that runs to the surface. While Savery's invention did succeed in removing water, it was incredibly inefficient, and the length of the pipe to the surface with no pumps along the way meant that large amounts of pressure were needed to carry the water, which often caused the pipe to burst, needing replacement. So in 1712, Thomas Newcomen improved Savery's invention by turning it into a proper engine. Instead of using the power of the steam to directly push the water, the steam would now escape into a cylinder with a piston inside. The force of the steam pushes the piston up, causing an attached lever to be pushed down. A bucket could be attached to the opposite end of the lever to collect water. The force of gravity then pushes the piston back down, raising the lever and the bucket of water to the surface. Although Newcomen's improvement allowed water to be pumped out of the mines at deeper depths, it was still inefficient because it relied on the insertion of cold water into the steam reservoir to cool and condense it, meaning that there was lag time following a pump to wait for the cold to heat the steam reservoir back to its hot temperature before the reintroduction of the cold water. In 1720, Jacob Leopold increased the power of Newcomen's steam engine by adding a second piston that operated opposite of the first piston. A final major improvement occurred in 1769 when James Watt added an additional reservoir to the engine to separate the steps of steam collection and condensation, eliminating the need to reheat the reservoir after every stroke and reducing the amount of coal needed to produce the same amount of work by 50%. At this point, the steam engine was very much an English invention and only found in areas with abundant with coal. With Watt's improvements, many applications of the steam engine began to become economical. The English were now able to construct inland factories and mills that ran off of steam power rather than hydropower, which had necessitated the plant be previously on an able river. This set off a chain of inventions in Britain that quickly thrusted the world into the Industrial Revolution. A system of carts and rails were installed to transport coal from the top of mines to waiting ships at the dock below. Initially relying on gravity to get down the hill, a steam engine was soon attached, creating the steam train, which allowed coal to be transported across all of Britain wherever a track was laid. Steam engines were attached to ships, rendering sails obsolete and increasing travel speeds. The need to resupply the steamships with coal helped rapidly spread the practice of coal mining around the world, with the British establishing mines in strategic locations. While mercantilism and the goal of acquiring the most gold possible helped kickstart global trade with its impetus for advancement in shipbuilding and navigation technologies, the actual goods of value being traded tended to be spices, salt, and other flavorings to enhance the taste of bland Northern European food. The problem with mercantilism is that amount of gold takes a lot of labor to mine and refine, and when it's finished, it doesn't improve the efficiency or real quality of life for the people of the nation acquiring it. With Adam Smith's revelations in the ensuing Industrial Revolution, coal took over as the dominant commodity which powered the world economy, not gold. Coal as a commodity was much more useful as it was able to power factories and mills, which increased the real wealth of the nation. Similar to coal, crude oil had been used by societies who resided in areas where it was readily available, often flowing above ground like one would see in a river. Almost since the discovery of pottery, potters were making the first primitive clay oil lamps, which were essentially a small dish that contained a hole to pour oil into and another to ignite a flame. By 500 BC, the Romans invented the candle made from beef fat, which was cleaner and more efficient than the primitive oil lamp. The technology advantage remained in the candle's favor until Swiss inventor Amy Argand invented the Argand lamp in 1780. The Argand lamp had luminosity equal to 10 candles and thus became very popular quickly, although it relied on burning whale oil, which was cleaner than the unrefined crude. Demand for the Argand lamp caused the practice of whaling to grow rapidly during the end of the 1700s, going into the 1800s to the point that whales around the world were at risk of extinction. It was from the unlikely place of an English coal mine where the alternative for whale oil and savior of the whales would be discovered accidentally. Here in 1847, chemist James Young noticed a black liquid dripping from the walls of the coal mine. Once he figured it was oil, Young collected some to study. He noticed by applying heat to the oil, he could separate it into a thicker oil used as a lubricant, as well as the byproduct paraffin wax, which could be used in candles instead of animal fat. A few years later, in 1850, Canadian Abraham Gesner discovered you could get greater amounts of oil from shale rock rather than from coal deposits. Gesner heated this greater quantity of oil to refine it into a material he named kerosene. Kerosene was the most efficient oil seen thus far and became a major source of lighting in the US by 1854. Demand was so great that Gesner's company was unable to keep up with the supply required until the discovery of petroleum, or liquid crude oil, existed underground and could be extracted and more easily refined into a variety of applicable oils. This liquid crude was first discovered in Titusville, Pennsylvania, when residents noticed black liquid spewing from a spring. An ex-railroad man, Edwin Drake, was bored of retirement and decided to get involved to see if he could turn the spring into an operating well. To construct the well, Drake purchased a steam engine and attached a drill bit to burrow deep into the ground. Drake's well was successful and started the Pennsylvania oil rush, although the U.S.'s initial lead in oil production was quickly surpassed when the Russian Empire constructed the world's first large-scale refinery at Baku, which is now the largest city in present-day Azerbaijan. At this time, Baku drilled and refined 90% of the world's oil. By 1895, a larger oil boom in northwestern Ohio, situated around the city of Findlay, had overtaken Pennsylvania as the largest oil-producing state. This feat was quickly overshadowed in 1901 by the incredibly oil-rich discovery in eastern Texas at Spindletop, where Anthony Lucas struck so much oil it initially spewed uncontrollably as a geyser. A rapid succession of oil field discoveries in California, starting in 1920, caused the state to take first place in crude production, although it lost its crown to Oklahoma for a short while, starting in 1927. By 1930, however, the Texas oil prospectors had spent considerable time and money on finding new oil fields in the state and were stunned with the discovery of the humongous Permian Basin in West Texas, which ended up becoming America's top producing area. As automobiles became increasingly popular as the century progressed, oil, particularly when refined into gasoline, became a consumer staple. During and after World War I, global powers invested money into upgrading their coal-powered steamships to more efficient ones powered by oil. Oil became a resource of national security importance and was a driving force in why Japan and Germany invaded and occupied key areas during World War II that had access to oil reserves, and why the U.S. forged a strong partnership with Saudi Arabia after the war to secure their access. By 1955, oil had replaced coal as the dominant heating fuel of the world. It is important to note that there are three main categories of coal based on its carbon content. The type that burns the cleanest is anthracite coal, which is required to be greater than 86% carbon. Anthracite is also the rarest type found, with the world's largest vein being in northeastern Pennsylvania around the city of Scranton. This scarcity helps move most of the commercial and residential heating to be oil-powered. 80% of the world's readily accessible oil reserves exist in the Middle East, and this fact ensued that the area would be a point of interference for global powers to try and exert control over these reserves. The Organization of the Petroleum Exporting Countries, OPEC, was formed as a cartel in the 1960s by oil-producing Arab nations to safeguard their oil and sovereignty, and which now exerted greater control over the supply. This new power was displayed in 1973 when OPEC put an oil embargo on Western nations who supported Israel, severely hurting developed nations' economies and sent them into a decade of spiraling inflation. The power of OPEC to unilaterally control global oil prices continued until the 2010s when prospectors in the US and Canada discovered a new way to drill for oil called hydraulic fracking. Fracking shoots large amounts of pressurized water underground against a shale rock formation to release oil that would have otherwise previously been inaccessible. The new technology, matched with enthusiastic support from the Obama administration, created a fracking boom all over the country, but most notably in North Dakota and the oil sands of Alberta and Canada. This boom allowed the U.S. to surpass both Saudi Arabia and Russia in oil production by 2021, providing the U.S. greater energy independence, consequently decreasing the power of OPEC. After fracking, the U.S. even started to become a net energy exporter, a role which proved to be lucrative in the wake of the Russian invasion of Ukraine and ensuing embargoes placed on Russian oil and gas. The other two types of coal have continued to be used in the U.S. for certain applications, although this use has been trending downwards. The lowest quality coal, which can be classified as either lignite or sub-bituminous coal, has a carbon content below 45% and is used primarily for powering steam turbine power plants. This dirty coal can be easily extracted from surface mines and is mostly found in Wyoming. The closure and replacement of coal-fired power plants is the primary area where coal usage can be reduced today, as we have already largely moved away from anthracite in its uses. The third type of coal, bituminous coal, has carbon content between 45 and 86% and is found most abundantly in West Virginia and southern Illinois around the city of Carbondale. Bituminous coal is used to produce coke, which is a smelted version of bituminous coal, which burns incredibly hot and is used to produce steel. The carbon released from the coal is required to strengthen the steel. Because of this, the use of coal in the production of steel is one application that does not appear to be going away anytime soon. The outlook for oil production is also changing as we migrate away from gas-powered engines to electric motors. While this trajectory may look to the average person as a rapid shunning of oil and a complete stoppage of production, which should occur soon, this view fails to realize the many uses of petroleum-based products, especially plastics, which now impact almost every aspect of our lives. A cleaner near future in this space may instead mean capturing carbon that would otherwise be released and pumping it back underground. The risk now is that overhype for new green technologies are causing market forces to prematurely abandon oil and gas while we are still relying on them, and thus failing to make investments in the infrastructure necessary to maintain the system. This is illustrated by the fact that the last oil refinery to be built in the U.S. was established in 2009. The infrastructure needed to refine oil into gas is massive and complex and only makes economic sense when producing fuel in large quantities. Therefore, during this transition phase, we will be met with the challenge of finding the right mix of decreasing fossil fuel production at the same time as maintaining and repairing current infrastructure. If we can do this successfully, then we will have a smooth transition to an electric dominant world where the new commodity that dictates power will be rare earth metals.